Okay, let's see what you remember from yesterday. What type of hydrocarbon is a molecule containing one triple bond? Remember the letter Y. Alkynes. Okay. What is the total number of hydrogens in a butene? So you would have to go and look up what but means. It means 4. Well, it's got an ene, so you look up the general formula. Okay. And then you should come up with the number. What type of hydrocarbon is saturated? Alkenes and C3H6. Again, you go to your reference table. You look up that right there. It's alkenes. Good. Again, table Q is your best friend in all this. This is all reference table. So you're happy. The identification by general formula. What is, or what if you are asked a given molecular formula of a hydrocarbon, such as C6H12, and ask what type it is. So you would go to the general formula, you would go back to here, okay, and you would figure it out. So you know that would be an alkene because right here, N is 6, 2N there, therefore is 12. And you know that's an alkene. Here is where you write your general formula. Here's the name. Here's the UPAC name. General formula, name, the UPAC name. Okay, why pent? Why prop? Prop is 3, pent is 5. What is 4? Bute, very good. Not but bute. And an I in there. Alkynes. Was I supposed to talk about these yesterday? Maybe I was. Alkynes are hydrocarbons that contain at least one bond, one triple bond. Alkynes are saturated or unsaturated? Well, look it up here. Do they have stuff on all sides? No. Okay, again, use table P to name them. And add an ine. So what is the molecular formula here? 2 is S, add an ine. You guys are going to answer these and then answer these. That's what it should look like. Okay. And then we have hydrocarbon substitution groups, or what Mark Rosengarten calls the dingle dangles, the dangle off the dongle. He does a whole video on that. So I'm just going to zip through this really quick. Hydrocarbons can have other atoms or groups that are added to them. Right, we call those dingle dangles. So then you have the alkyne groups. They're alkane molecules that have one H removed, allowing them to stick to the hydrocarbon. So methyl, right? You look up meth. How many carbons does it contain? 1, right? And you should be able to draw 2-methylpentane. How would you do it? You would, pent is 5, so you would draw 5 carbons. And then on the second carbon, 2, you would put a methyl group. If you put it on the first group, then you have hexane. Okay, methyl group contains ethyl group 2 carbons. So you should be able to draw 3 ethyl hexane. So you would draw hexane, which would be 6 carbons in a line. And then on the third carbon, you put an ethyl group. This is where I was supposed to stop. Yesterday or today. So I'm just going to post this as a part 2. And actually end here.